All right, the purpose of this is just to remind you of what we were doing before Thanksgiving break, and that was balancing chemical equations. And we balance chemical equations in order to satisfy the law of conservation of mass. And what the law of conservation of mass told us was that we can never create or destroy matter or mass in a chemical or physical change. And so essentially what we were doing is we were taking examples like the following, where I had sodium reacting with, let's say fluorine to produce sodium fluoride. Now, what we would have to do is then look and see that we have sodium involved and fluorine involved. And so we have one sodium on this side, two fluorines, one of each on the other side, noting that the fluorines are not equivalent, adding a coefficient only to make this problem go away. But two fluorines means two sodiums, and so then we had to come over and add a 2 over here as well. So that should be your basic reminder of how to balance a chemical reaction. Now, if you'll remember, we also added into the mix the idea of reaction patterns. We had 5 patterns that we looked at on the Tuesday before Thanksgiving. And those 5 patterns were synthesis, where we added 2 things together to make one. We had decomposition, where we had one thing breaking down into more than one. Next, we had single replacement. And in single replacement, we had an element reacting with a compound and displacing one member of that compound. We also had the idea that this could not happen if I had an element trying to replace a more active one. As given by our activity series, we knew that this would not happen. Next, we had metathesis, which your book refers to as double replacement. So in metathesis, we had 2 compounds reacting in order to produce 2 new compounds. And finally, we had combustion. And combustion was a reaction with oxygen so that we were burning things. And more specifically, we tagged this as hydrocarbon combustion. And we said that complete hydrocarbon combustion produced carbon dioxide and water, whereas incomplete hydrocarbon combustion would produce carbon monoxide and water. And so I left some problems to do. Some of you said that there were problems getting to those. Well, we fixed that issue by putting a picture on the blog. I do realize there was some issue with that, but it's been resolved. So if you would go to the blog, the top post now contains the document with the problems. And so if we bring those up, we can see that list. Now, I'm going to leave copies of this here for you to work with. So I just wanted to show you where you could find it at home if you need it. Otherwise, we'll just begin working on these problems from here. And so I wanted to do a few of them with you. And so we'll start with number 1. Number 1 on that sheet says that hydrogen gas. Well, if you remember, hydrogen is H2. It's a diatomic, one of the 7. Hydrogen, nitrogen, oxygen, and all of the halogens. And it says it's a gas. So H2 gas reacts with means plus oxygen gas. So that's O2. That's one of the diatomics. To form means arrow. And then it says liquid water. So water is H2O, and we'll tag that as a liquid. So now we've written the equation per what they gave us, but we have not balanced it. We have 2 hydrogens on this side, 2 on that side. That's fine. 2 oxygens here, only 1 there. That's an issue. So there are more than one way we can do this, but what we'll do is we'll just use whole numbers just so that everyone's okay with it. So the first thing I need to do is multiply by 2 to get my 2 oxygens. But that also gives me 4 hydrogens. And so on the other side, if I multiply my H2 by 2, that's also going to give me 4 hydrogens. And now we're obeying the conservation of mass, and we have a written balanced chemical equation. And the last thing they asked me to do here is identify the type. I have two things becoming one, and that is the hallmark of a synthesis reaction. You might also call this combination or addition. That's acceptable. Next example I want to do with you is number 6. Number 6 takes calcium hydroxide, where I have calcium and hydroxide, where calcium is positive 2 and hydroxide is negative 1. So when I swap my charges for proper writing, I'll see that I need 2 hydroxides with my calcium. Reacts with is going to be plus. Phosphoric acid is H3PO4. And that's going to produce something. Well, in this case, we need to know what type of reaction this is before we can predict. I have 2 compounds reacting. This is going to be a metathesis. When I have 2 compounds reacting, we're going to call it metathesis. And so we're going to trade partners. Calcium and hydrogen are going to swap who they're bonded to. So calcium is going to join with phosphate. Now, it doesn't mean that I just stick calcium where hydrogen's at. I have to go ahead and go in and reswap the charges. So my plus 2 calcium is going to bond with my minus 3 phosphate, such that I get 3 calciums and 2 phosphates. And additionally, I'm going to put H and OH together. So when H gets with OH, that is H2O. So now I can start balancing. I'll start with calcium. It's going to take 3 calciums to get this done. It's going to take 2 phosphates. So both of those are handled. Now we look and we see that we have 3 times 2, that's 6 hydroxides. And 2 times 3, that's 6 hydrogens. So if I have 6 hydrogens and 6 hydroxides, together they make 6 waters. That's not a 16, that's a 6. And so now we're balanced. And we said this was metathesis. All right, also number 12. Number 12 was one that several classes asked me to work. If we look at this and we take copper, metal, and react it with silver nitrate, Ag plus 1, nitrate minus 1, so that's fine. Solution means aqueous. The only option I have here is for copper to replace one of these two. This is a single replacement. Element plus compound equals single replacement. And so if it switches, it'll switch with the metal so that copper can replace silver. So I will get copper with nitrate, where copper is usually positive 2, nitrate is minus 1. So I should require 2 nitrates, and silver will get put out by itself. So now we've written element plus compound equals compound plus element. That's single replacement. So if we want to go ahead and tag that, we can do so. And we can go ahead and balance as well. 2 nitrates on this side requires 2 nitrates on that side, which will then require me to add 2 silvers to this side. And so away we go. Another one that they asked me to work, number 14. Number 14 dealt with sodium chloride being dissolved and dissociated. When I dissolve something, it means I put it into water. When it dissociates, the water actually breaks it. So when sodium chloride breaks, it becomes Na positive, aqueous, because water did the breaking, and Cl minus, aqueous. This does not fit one of your 5 patterns. This is called dissociation. It's just something that you need to be aware of that can happen. And then I believe it's number 15 also. They asked me to take a look at. If this is the wrong number, I apologize, but I think it's number 15, where we have chlorine gas being bubbled into, that means plus, magnesium chloride in solution. So that's aqueous. If I were to look at the type for this, this would be single replacement. I've got a nonmetal trying to replace the nonmetal in here, but look, chlorine and chloride, same element. So if I were able to do the replacing, everything would cancel out. So this would be a no reaction. If it were to happen, it would be a single replacement. So now I've worked some examples for you. I'm going to leave basic balancing off this discussion because we did plenty of that before. And so I'm going to leave you the rest of this sheet to work. There may be a couple more of these answers on the blog. I'll leave a link to the blog for whoever is teaching your class so that they can go out and take a look at it as well. And then I'm going to leave you this and some other practice problems to work on and a practice quiz. And so you should be all ready for a regular quiz on this on Thursday. I'll leave the quiz and the answers. If you have any questions, you can email me.